We are now on the move. In the previous video, we looked at the organizational statement. They came up with this general statement that, wow, we want, we have a problem of changing the background color of our system. We want a system that can change red color to yellow whenever the current light color is red. So I told you that the organization know exactly what they want and they know why they want what they want. Maybe they need this as a traffic light system so that they can sell and make some money. They know that. And they know exactly what the problem is. You see, they say they have problem. They have problem. And the problem is changing the background color. They cannot change the background color of their system. So this is a general statement. This is a general problem. And in my model, this problem equates to the A we were talking about previously. The problem actually equates to A. Yeah, to A. Yeah, and the solution to change the traffic light from red to yellow is B. And we model problems as being vectors, and that solution, we say the problem must terminate in finite time. So maybe that vector is moving that side. But this is the problem space, this is the solution space, So we now need to find the solution to the problem, which is going to be the linear combination. The solution is going to be the linear combination of A neo in order to get B. So it's just a function that we're going to apply on A in order to get B. So the overall solution will be the A transform times B. So B has to be the ingredient of A transform just to measure if the expected solution is commensurate with the problem so that the company can accept our system. All right. So this is what they found. They defined the problem as what, and they know why. They did not tell us why there, but they want their traffic light to change. I mean, they need to be able to change the background color from red to yellow, and that is what they want to do as well. So we have the knowledge of this. We have the knowledge of what they want to do, and we understand that they don't know how. That's why they contacted us now to come and start providing the solution to the problem A, which is on the screen here. This is the problem they have. Now, as engineers, we know that this is a general requirement, and this is what is called a complex system. It's the world problem. It's the real world problem that we want to solve. So when you are faced with a situation like this as a software engineer, if you know what you're really doing, then you start questioning yourself of what to do next. Rather than going to start programming, trying different programming languages to write codes. So what we need to do now is we have to break the requirement into specific requirements for both functional and non-functional requirements. Remember what we discussed in the previous video concerning the methodology of solving algorithm, to solving computational problem. We talked about the top-down approach, and we talked about the bottom-up approach as the strategies, and then we talk about the methodology, and methods are the processes. That's where we are going to do the breaking and going through step by step. But the methodology is the plan. Is the plan of what we want to do in order to achieve the goal. And that plan now is what we have now. We have to break the requirement into specific requirements for both functional and non-functional requirement. So I know as you have not yet tackled or done anything about software engineering, functional and non-functional requirement may be something very new for you, but they are not very complex to understand. Function requirement, functional one, are what the system should do. It's like what should be done in order to turn the traffic, the red light to yellow. And then non-functional requirements are the requirements. What abilities, what capabilities should the system that we are going to run the functional requirements on should have in order to allow our system to work. So in terms of non-functional requirement, just look at it like the system. For example, the computer system you have, the specification of the system must be running, the system must have a high-speed processor or things like that. You know, the capability of the system to allow you to design the demanded system that the stakeholder would like us to do. So that's the difference between functional and non-functional requirement. You will learn them in my software engineering course in details, but from here we need to break those requirements down. So how do we do it? We want to change the red light with red to yellow. That's what we want to do. That's the plan. That's the plan. So we are going to apply what is called a top-down approach, whereby we are going to start by breaking this thing into smallest particles, and then we will find solutions by coming up with functions for each of the broken bits, and then stick it together at the end to come up with the overall system that they want to change the light from the background light, the background color from red to yellow. So the first thing we are going to do is that we are going to break this requirement to see what the system should actually do. So the system should define the current color of this. The system should define the current color of the system red model as the input. Yeah, and then the system should define the expected color of the system yellow model as the output, and then the system should be able to link A to B to distinguish the color. And then the system should reverse or transform the current color rate, which is A, to match the expected output color B, which is yellow. So the system should select the value of the transformed problem, compare it to the expected output to produce the result that we want. So each requirement is a function. You see, we have like about how many requirements now? We have like 5 requirements. But before that, you know, we have to know the general requirement first, which is the bigger complex problem, this one. Now we have to break it into pieces, and we're broken them into smaller, different requirements. Now we have to solve this one by one, or write a function or algorithm one by one to sort out this thing and stick them at the end to come up with the overall solution. Now, in terms of non-functional requirement, the system shall be able to take input, process it, and output it within limited delays. With limited delays, that I mean to say within a short period of time. So time and availability, and then other capabilities of the processor and the machine that we are going to work on will be our non-functional requirements. Whereas all these things here that you see are going to be our functional requirements, and this is what the system should do. So my friend, thank you for viewing. I hope this video has been informative. What to take home from this video is the general requirement, which can be modeled as the complex system, you know, which is very complex. And how to solve it is breaking it to functional requirements, which are here, so that it becomes small. Each of these are, each of these correspond to the problem that has been defined there. So each of these is a solution. Now we will equate each of these to be the function and then get the solutions for each of them and stick it together to find the, the general solution to the big problem there. You see, that is how to solve uh, problems in the world. We are using a bottom-up approach instead of using, we are using a top-down approach. The other approach is bottom-down, which is not, it can be used here, but we are not going to use it. So this is the function I want you to see before you go. We got about 1, 2, 3, 4, 5 functions. Each of them represents these small requirements. And we are going to apply these functions on the linear combination of A until when we get uh, up to the final answer. So we are going to start solving it one by one. We're going to find a solution for that. Go to H, find a solution for that. Go to J, find a solution for that. Go to H, find a solution for that. Go to Y, find a solution for that. Then stick everything to come our solution to the problem so that the company can be able to change their background color from red to yellow. So I hope this has been informative and thank you for viewing. I will see you in the next video as we continue with our process to develop a computer system. My friend, this is how to develop a computer system. This is how to design a software system. You are learning software development before even reaching there. I'm glad for that. I see you in the next video.